Hi everyone, for today's lesson we are going to learn how to solve absolute value equations. Our learning objectives for today is for you to be able to say, I can solve absolute value equations graphically, which means that not only will we be graphing and you will need a straight edge for today, but we will also be using our graphing calculator. So if you can make sure that you have access to those supplies before we get started, that might be a good thing. Our other learning objective is for you to be able to say, I can solve absolute value equations algebraically and recognize when you have extraneous solutions. So our warm-up for today is to solve the following system. And a system simply means that you are graphing one or two or more functions or graphs on the same exact grid. All right, we have ourselves an absolute value function, and in this absolute value function, our vertex is going to be located at the opposite of what we see inside, which is -1, and then exactly what we see on the outside, which is 5. So -1, 5. Our A value in this case is -2. So please go ahead and pause the video and graph this absolute value function. All right, so hopefully you went over to where -1, 5 is. And then the slope of the right-hand side is -2, so you would have gone down 2 to the right 1, down 2 to the right 1. And I like to come up with as many points as I can. I think that it looks nicer when you do that. That's just a personal preference. Remember, I only require you to have 3 points. And then I'll use my straight edge to draw my absolute value. Next thing we have is the line y equals 3. This is y equals, and y equals is a horizontal line when it's just a number. Y equals 3 is a horizontal line. So I'm going to go up to where 3 is, and I'm going to draw a horizontal line along where y is equal to 3. So before I continue talking about this, what I want to talk about is this idea of horizontal line versus vertical lines. And I have a little phrase, and you might have heard it before, and it's called Vux and Hoy. So I'm going to talk about Hoy first, since we just graphed a Hoy. Hoys, that means horizontal line. They have 0 is the slope. Flat lines have 0 slope, and y equals a number will be your equation, H-O-Y, Hoy. The next thing that we have is a thing called Vux, and that represents vertical line. U represents the word undefined slope. And finally, x equals a number is what the equation looks like. Vux and Hoy. This is something that you learned when you were in Algebra 1, and it does come back quite a bit in this class, throughout this class. We even talk about Vux and Hoy all the way up in March, so that's kind of a cool thing. All right, so remember that a system of equations, whenever you solve it, the solution of a system of equations is where the graph intersects. And the graph intersects in 2 locations. It intersects at this point and this point. And so if we want to talk about those solutions in this case is the ordered pair 1, 2, -2, 1, 2, 3, -2, 3. And the other ordered pair is located at 0, 1, 2, 3. So these are our 2 solutions, 2 points of intersections of this system of equations. Now what we're going to do in this lesson is we're going to actually solve equations, and they are related to systems. Now to solve an absolute value equation, in the form of the absolute value of ax plus b equals c. Notice once again that the absolute value is alone. That's going to be important. We follow the following steps. So step 1 is to isolate the absolute value. That means that you need to get rid of any addition or multiplication, anything that's on the outside of the absolute value before you even get started. So what I'm going to do is I'm going to go through the steps and I'm going to solve this equation at the same exact time. So step 1 is to isolate the absolute value, and in this problem we have negative 2 times the absolute value of x plus 1 plus 5 equals 3. Now, if I gave you the problem, and I'll just put it on the side, like negative 2x plus 5 equals 3, your first step would be to naturally get rid of the 5. And that's exactly what we are going to do first. We're going to start by subtracting 5 on both sides. So the 5's go away, and we are left with negative 2 times the absolute value of x plus 1 is equal to negative 2. Cool. So I do that over here. I'm left with negative 2x is equal to negative 2. And then our next step is for us to divide both sides by negative 2. And that's exactly what I'm going to do over here. I need to get the absolute value alone, so I'm going to divide both entire sides by negative 2. The negative 2's cancel away and become a big fat 1. And we are left with the absolute value of x plus 1 is equal to 1. Cool. This over here is x equals 1. So they are related in how you solve these problems. All right, next, step 2. Now that we've isolated without using the absolute value symbols. So we are going to drop those absolute value symbols. So without using absolute value symbols, we are going to write 2 non-absolute value equations. And those equations are ax plus b equals negative c and ax plus b equals positive c. So here are 2 equations. We're going to have x plus 1, dropping our absolute value symbols, is equal to the opposite of what we see that it's equal to. So the opposite of 1 is negative 1. Then I'm going to write the word or. We always talk about the word or. We have x plus 1 is equal to positive 1. It's exactly what we had originally written, just no absolute value symbols. And now we're going to solve each equation individually. So I'm going to subtract 1 on both sides, and I end up with x is equal to negative 2. I'm going to subtract 1 on both sides, and I end up with x equals 0. So our 2 solutions are x equals negative 2 or x equals 0. Now what's really important is after you have solved each equation individually, just like we did here, the next step is to check each solution back into the original problem. And we're checking for extraneous solutions. This is a step that I'm going to be looking for every single time. You have to check back into the original, not the one that you isolated. Because what if you made a mistake? That wouldn't be a very good thing for you to plug something back into something there where you made a mistake. That's not good. So anyways, we check back into the original problem, and so I'm going to write negative 2 times the absolute value of negative 2 plus 1 plus 5, does that equal 3? Now, you don't have to show me a tremendous amount of steps in your check step. Just get to a logical point. I certainly need to see the substitution into the original problem, and then maybe 1 or 2 lines of logic. So this is negative 2 plus 1, which is negative 1, and the absolute value of negative 1 is positive 1. So this is negative 2 times 1 plus 5. Is that equal to 3? Negative 2 plus 5, that equals 3. 3 equals 3. So yes, that works. And now I'm going to check x equals 2. I'm going to write negative 2 times the absolute value. I'm going to check 0 into my next problem. So I'm going to write negative 2 times the absolute value of 0 plus 1 plus 5 on the outside. Does that equal 3? So 0 plus 1 is 1, and this is negative 2 times 1, which is negative 2. Is negative 2 plus 5 equal to 3? Yeah, 3 equals 3. That is an absolutely correct answer. So in this particular problem, we have two solutions, -2 and 0. And if you notice, this problem up here was -2 times the absolute value of x plus 1 plus 5. That's exactly what we had right here. And we had y equals 3. We set it equal to 3. So what do you notice about example 1 in our warm-up? Well, they're basically the same thing, only we're writing it as an equation. And where are these two linears, or an absolute value and a linear, equal to each other is at the points of intersection. And our answers ended up being -2 and 0. And where did we see -2 and 0? Well, right here. They were the x parts of our ordered pairs, the x parts of our solution. So I'm going to write down that the x coordinates are the solutions of the equation. It's always fun how things are connected, and that's kind of a cool thing. It's the x coordinates. All right, in example number 2, it takes things to the next level. We have ourselves an absolute value is equal to a linear expression. And so we're going to follow the same exact steps, but this time we might fall into a thing called an extraneous solution. So I want to define what an extraneous solution is. As an extraneous solution is a solution you obtain when solving an equation but it does not make sense or work in the original problem. Does not make sense or work in the original problem. So therefore it's a solution that you're like, that doesn't make sense at all. All right, here we go. So in this problem, going back to our steps, it says isolate the absolute value, and in this problem our absolute value is isolated. So therefore we go on to step 2. Without using absolute value symbols, write as two non-absolute value equations. So I'm going to drop the absolute value symbols and write this as 15 plus m equals, and now notice it's -c. So that means I'm going to put a negative symbol on the outside, and I'm going to put in parentheses this entire expression of -2m plus 3, the whole expression. I'm going to write the word or. I'm going to write 15 plus m is equal to the expression as written, -2m plus 3. Now, some students might say, hey, this is a negative. Wouldn't that mean like the whole side could be negative? Well, let's think about that idea. What is -2 times a negative number? A positive number. So this expression, although it looks negative, could be positive. So you have to kind of be careful and use a little bit of mathematical logic and sense of numbers whenever you're looking at these types of problems. All right, next step is to solve each problem or each equation individually. So let's go ahead and do that. So I have 15 plus m is equal to, I'm going to distribute that negative to each term. And I have 2m minus 3. I like to have the coefficients of my variables to be positive. So I'm going to subtract m on both sides, and I'm going to add 3 to both sides. I like to do more than one step in one step because I can anticipate what's going to happen. So the m's are going to go away and the 3's are going to go away, leaving me with 18 is equal to m. All right, cool. Or, I'm going to write the word or. We have 15 plus m equals -2m plus 3. I like to have my coefficients be positive, so I'm going to add 2m to both sides. And I'm going to subtract 15 on both sides, doing more than one step in one step sometimes saves us time. And I'm left with 3m is equal to -12. And dividing both sides by 3, I find that m is equal to -4. So these are our two solutions that we now need to check. They're either maybe one's going to be extraneous. A lot of times students automatically think that one's going to be extraneous over the other, so you have to really be careful that you don't fall into traps. So here is my first check. I'm going to check 18, and I'm going to write the absolute value of 15 plus 18. Is that equal to negative 2 times 18 plus 3? So 15 plus 18, that is 33. So is the absolute value of 33 equal to negative 2 times 18 is negative 36 plus 3. Is 33 equal to, absolute value of 33 equal to negative 33? And the answer is no. Remember, absolute values, whatever goes into an absolute value is automatically positive because it represents the distance that a number is away from 0. So the answer in this case is no. 18, even though it was a positive solution, turned out to be extraneous. So 18 is an extraneous solution. Next, we are going to check negative 4. So I'm going to write absolute value of 15 plus negative 4. Is that equal to negative 2 times negative 4 plus 3? So this is 15 plus negative 4 is 11. The absolute value of 11, is that equal to 8 plus 3? Negative 2 times negative 4 is 8. Yeah, I'd say that 11 is equal to 11. That is a true statement. So therefore, our only solution in this problem is simply m is equal to negative 4. So once again, it goes with that logic of just because something is negative doesn't mean that it's automatically going to be no solution. And this checking your answers, once again, is going to be a required step whenever you are solving these problems. All right, the next two problems are your turns, ones where you will work with on your own, and then we will discuss them together. Maybe you'll work with your partners on them. So if you would like to do them on your own, you're perfectly fine to do that. If you want to wait, that's fine too. All right, this is the part of the lesson where you will need a graphing calculator. And what we're going to do is we are going to solve this problem and then verify our answer using our graphing calculator. And we're also going to verify our last example that we just did as well. So let's go ahead and look at this example. And remember that just like we did before when we were using our graphing calculator in a previous lesson, we separated the equation into two pieces. Like this side was y sub 1 and this side was y sub 2. And that's exactly what we are going to do in this problem. So I want to verify the solutions of only being m equals negative 4 in this problem. And so what I want to do is I want you guys to let y sub 1 equal the absolute value of 15 plus m. And I want y sub 2 to be equal to negative 2m plus 3. And what we want to do is we want to verify that solution of m equals negative 4. Now remember, m is in that x position, so when you enter it into your calculator, you'll need to use the letter x. So I'm going to clear out what we did before, and I'm going to insert absolute value of 15 plus m. So remember, absolute value is located right here at math. I'm going to press the right arrow to where it says num, and I'm going to put in absolute value. And inside I'm going to put 15 plus x, because x is like our unknown, like m is our unknown. Then I'm going to press the down arrow to where negative 4 is. And now we're going to check out the system of equations by pressing zoom and then standard. Our standard is at 6, and we'll see if this looks okay. I can't see much, so it looks like we're going to need to expand out the window so that we can actually see what's going on. So I'm going to go to where my window is, and I'm going to change, looks like all of my information is over on the left, and I really can't see what is going on. So I'm going to adjust it so that I can see more negative x values and maybe even see more negative y values. So let's go ahead and press window, And I'm going to go down to my x minimum, and I'm going to see if maybe it makes sense for me to change it to maybe like negative 20. Now let's see what happens there. Oh, look how nice that is. Oh my gosh, what am I doing? Why did I put in negative 4? I'm so sorry, guys. We needed to put in negative 2x plus 3. I'm like, this isn't working. So yes, so this is our y sub 1, this is our y sub 2. I'm so sorry. We're not able to see what's going on with our graph because you can't see it. So anyways, here's my first function. And I can't see what's going on up here. So even though I can see the absolute value, I can see this right here. I'm not able to see that point of intersection. So that means I need to go a little bit higher on my window. My y values, my y maximum needs to be a little bit taller. So let me try 15 just for fun. I changed my y value, my y max to be 15. There we go. Cool. I can see that point of intersection, but how can you actually tell where that intersection is? I know that it's supposed to be negative 4. I can kind of guess that it's at negative 4. But one of the ways that you can do this is by pressing second and then trace. And you can look for intersect, where they intersect, number 5. So you would move your cursor to where it says first curve, and you would probably, you know that it's supposed to be negative 4. So I'm going to make my x value get as close to negative 4 as possible. And I'm going to press enter. My second curve, I'm going to move it so that it is as close as possible to negative 4. And it's going to say, do you agree with that? I'm going to say sure. I'm going to press enter again. And then they're going to ask you, is that your guess? I'm going to say, yeah, it's my guess. Enter. Boom. Right there. Negative 4 is my x value, and that is my point of intersection. And more specifically, that ordered pair is negative 4, 11. And we know that whenever we're looking at solutions, it's always the x part of that ordered pair. All right, cool. So let's go ahead and look at this problem right here. It says, if we want to solve this equation, verify our answer with the graphing calculator, check for extraneous solutions. And once again, we know that we need to isolate our absolute value. So I'm going to start off by subtracting 5 on both sides. Remember this plus 2, this is 2 times our absolute value. And so we need to get rid of addition and subtraction first. So I'm going to get rid of the 5 on both sides, and I end up with 2 times the absolute value of x minus 4 is equal to negative 4. Now I'm going to divide both sides by 2, and when I do that, I'm left with the absolute value of x minus 4 is equal to negative 2. And I'm actually going to stop right here, because whenever you see that you have an absolute value of something equal to a negative number, this tells you that there is no solution, because absolute value represents the distance that something is away from 0. And how can distance equal a negative number? So at this point, I want you guys to simply stop and say an absolute value cannot equal a negative number. And so because it cannot equal a negative number, we have to say automatically there would not be a solution. There is no solution to this problem. So whenever you see the absolute value of something, absolute value of anything, equal to a negative number, this automatically means no solution. Now, I know that when we're in the throes of taking quizzes and tests, that we forget. We're like, oh, I have to solve this. This is something that I need to know. Like I need to show all of my work and all of my steps. And then you have all these students that will show. And what you'll find is that when you substitute all of these values, whatever values you end up with, back into the original, it ends up being a false statement. Therefore, you would end up with no solution. Preferably, I would like you to be able to just get to this step and recognize that you need to stop. That's my preference. But if you end up, you keep going and then you recognize that there's no solution, that's an okay thing as well. We're going to verify this with our graphing calculators. So I want you to put y sub 1 is equal to this side of being 5 plus 2 times the absolute value of x minus 4. And then I want y sub 2 to be equal to 1. And we're going to look at their intersection. So please go to y equals on your graphing calculator and clear out the other equations that we were just working with. And I want you to press 5 plus 2 times the absolute value, going over to where the absolute value symbols are, of x minus 4. And remember that whenever you're working with a different calculator than me, you might need to close the parentheses, so just be aware of that. And then we have y sub 2. We're setting it equal to 1 since that's what our equation was. And now I'm going to once again go back to Zoom Standard, because Zoom Standard always tells me, like, it's always a nice starting point and it gives me an idea of what's going on. And as you guys can see here, we have ourselves an absolute value and this line of y equals 1 where there is no point of intersection. And because there is no point of intersection, that indicates that there exists no solution. And therefore, well, we have verified our answer. That is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.